Okay, let me just say again, when we talk about inheritance, there's more than one way to talk about it. And um, I used to want to say that when you inherit, you're inheriting a particular implementation. And it sounds good. It's nice to talk about that way, but we're going to talk about inheritance as basically you inherit all the attributes and methods of the parent. Now, we got to get into details now. That means, like instance variables of the parent are normally private, so you can't access them directly from the subclass. So the object has those attributes, like here. Every J object has two attributes, X and Y. Subclasses could add more, but they will have an X and Y. So how does the K class get those? Well, it inherits them. Basically, you inherit all the members of the class, and constructors are not members of the class, so all the variables and instance variables and all the methods get inherited. And that's what we're going to talk about. Now, what does that mean? It means, every J object has those attributes and abilities that are specified in the J class. That's what we're going to say by inheritance. And by saying it that way, it goes in line with, like an interface is just a list of methods. And so, people say that, oh, we inherited the compare to method from the comparable interface. Not in this example, of course, but like the string class inherits the compare to method. But there's no code there to inherit. And so it just means that, a string object does have that method. Of course, it must implement it because the original was an abstract method. So, so here, even though we'll say that all three methods fun, back, and to string were inherited, K object has those methods, it doesn't mean it uses the original implementation. In this case, with fun and to string, it overrides those methods. And so, and the back method is one where the only implementation that exists is that in the J class. And so if you call the back method from whatever context, that's the behavior you're going to get because it's the only option. So let's go through this. How many instance variables does a K object have? 2. What class does the J class extend? And once again, yours didn't say this. That's implied. If a class doesn't extend any other class, then it extends the object class, as we said. And that's normally not stated. So normally it's just written like that. What does inherit? What I just said. Everything but the constructors. Which can you not directly access? Anything that's, private, mainly. Once again, there are two other possibilities, package and protected. If it's protected, that means it can definitely be accessed from the subclass. Once again, package, you have to be in the same package or same folder. And so, and strictly, protected, you have to be in the same folder or be a subclass. So I'm saying if there was a protected member, K in J, K could definitely access it, whether in the same folder or not. But if there was a package member, like for instance, if I deleted the word public or private anywhere, then those would all be package access. Then the subclass would have to be in the same folder. Okay, so anyway, that's the rules. Normally it's just the instance variables are private, therefore that's what you cannot directly access. Then if we look at which methods get overridden, that would be fun to string, like I said. And then now this question: does the K class truly extend the J class? And what I mean is, we use the word extends to, in the sense of added on, but does anything actually get added on? Well, no. If you look here, it overrode to the original methods, but there's no new methods added on and no new instance variables. So I would say no. Now, finally, what is the output? Once again, I would show the contents of the variables every step of the way. So you call the J constructor, it creates a J object, stores X is 3 and Y is 3. And when you print it, you call this toString method, which once again, don't assume, look at the actual code. And so you see 3 and 3, so that's the first line of output. And then you call, next we create a K object. Now the reference variable is J, and so this is where polymorphism kicks in. Once again, well, not yet. Right here, we call the fun method. That's where polymorphic behavior kicks in, because you have, Well, you have two fun methods. And so the compiler, all the compiler knows is that the J, one is a J reference to some kind of J object. So the compiler can't know at compile time what toString method and what fun method it was going to call. And actually, I almost messed up, but it didn't know which toString method it was going to call either, actually, because there are two versions of that. So at runtime, it called this JObjects toString method, and down here at runtime, it's going to call this KObjects toString method. So you're going to get different behaviors right there. Once again, the only way you wouldn't get polymorphic behavior is if you call the back method, because then there's only one back method, and so Java would know which code to bind with the method call. And so once again, here with polymorphism we're talking about dynamic binding, as in it knows, or it can't know until runtime which method to bind this method call to. In this case, it'll be the K method because it's K object, but it didn't know that at compile time. So anyway, to finish this, listen, if it's a K object, Java's going to look on the K class, the subclass first for any method calls. And so look in the K class, find a fun method, and run that code. And now it calls the back method. But once again, for every method call, no matter where the method call originates, it's going to look in the subclass. It is a K object. And so it's going to try to call the K version of any method. So it first looks in the K class for a back method, doesn't find one, so it's going to come up here and run this code. And so it returns 1, so the output of this line of code is 1. And then, once again, when I created this K object, by the way, I kind of skipped that, we call the constructor, but we don't see a constructor in the K class, so therefore it creates the default, which automatically calls the new argument J constructor, which gave it X and Y, set them both to 3. So, last thing, once again, this K object was storing 3 and 3 in the J part of it. And then when you call the toString method, once again, you're calling the K version. And so if you just put 3 and 3, you're wrong. It calls the K toString method, which essentially extends this toString method. Now, this is just to kind of show how things are pieced together. Really, the only data is part of the J class, and so you can argue that it would be better to not do that at all, because there's no new data to add on to it. Just have it automatically use the J version. But that was not what would happen. There was a K version of the toString method, so that's the method. That's the version that gets called. Okay, on to the next example, or the next problem. And once again, spend your time really studying the classes before you, and which is what these questions are meant to kind of guide you into thinking about. Don't just blindly start running this code without doing that analysis first. Okay, so if we look at it, there's 2 instance variables for methods. The in class doesn't add any new instance variables. And if you look at the methods, it has the exact same 4 method names. So it overrides all 4 of them in this case. So n has its own special behavior in every instance. Okay, let's go through this. Once again, how many instance variables does an n object have? 2, x and y. What does it inherit? Everything but the constructor. So x and y, fun go back to string. What does it override? Well, all 4 methods. Does it truly extend? No, not at all. It doesn't add any new instance variables or any new methods. Now, as far as output, by the way, let me say again, I said before, you have to be careful that the code even compiles, but the only time it won't compile is if the subclass adds on new methods, and you're trying to call that new method with a superclass reference. So if n had a new method and you try to use an m reference to access it, it wouldn't compile. I mean, that's not the only way it could fail to compile, but that's the biggest thing to look at with a structure like this with inheritance. But like we already said, there are no new methods, so that you don't have to worry about that. And that is kind of the point to this last question. Look for new things in the subclass, because that's going to, you got to be careful about, when you check for compiling. Okay, let's go through this. First, create an m object, and the constructor there sets x to be 8 and y to be 1. Done. you call the go method. Which go method? Well, this is easy because it is an M reference and it is an M object. So certainly you're calling the M version of every method call. So you call the M go method and you get the Y value, which is 1. What's tricky about these, by the way, the return type is double. Why? I don't know. To see if you're paying attention. So the answer is not 1, actually it's 1.0. Then you call back, and it's going to the M back method, which recalls the fun method. Which fun method? The M fun method, because once again, it's an M object. So you get the X value, which is 8, but it's a double. And then you call the fun method directly this time, so you get 8 again, 8.0. And then you call the toString method, which returns X and Y, so 8 and 1, and there you go. Now it gets more interesting. Now, once again, it's an M reference, and so the compiler will look in the M class for all these methods and find them, so it compiles. But then when you run it, you're going to run the N version of every method, and just keep that in mind. While we run this code, Java is going to dereference every method call by, when I say dereference, you're basically going to go and access this N object that stores 8 and 1, and get that N object to do what we wanted. So we asked it to, we call its go method. So we call, go method. It says super.back. Well, okay, fine. It says super.back. Therefore, we're calling the back method found in the superclass. But then that method calls the fun method. Which fun method? Well, it is an N object, so we're going to call the N fun method. That's what I'm trying to stress. Is it doesn't matter where the method call originates from. You're going to call. It's going to look in this subclasses, in the subclass for the implementation to run, the version of that method to run. And so you call the fun method. You're going to call the N fun method, which returns 7 as a double. So that first line of output is going to return a 7 as a double once again. Now we call the back method. We look in the N class, it returns 2 as a double. Then we call the fun method, and this, of course, is the N fun method. Then we call the toString method, and this toString method overrides the original, but all it does is call the original, which is pointless, frankly. And so the last question we have is, what method could be removed in the N class and get the same behavior? Well, that would be the toString method. It had no point at all. Alright, that is all. Soon we'll start adding on instance variables to the subclass.